Good morning, everyone. Today, our topic is NMR spectroscopy. NMR spectroscopy means nuclear magnetic resonance spectroscopy. Nuclear magnetic resonance spectroscopy is a branch of spectroscopy in which radio frequency waves induce transitions between magnetic energy levels of nuclei of a molecule. It is a form of absorption spectroscopy. The sample absorbs electromagnetic radiation in radio frequency region, and spectra arises due to the transition between nuclear spin energy levels. NMR spectrum is obtained by plotting frequencies of absorption peaks versus peak intensities. NMR spectroscopy is a powerful analytical technique used to characterize organic molecules by identifying carbon-hydrogen framework within a molecule. Two common types of NMR spectroscopy is used to characterize organic structures or proton NMR spectroscopy, carbon-13 NMR spectroscopy. Proton NMR spectroscopy is used to determine the type and number of hydrogen atoms in a molecule. Carbon-13 NMR is used to determine a type of carbon atom in a molecule. Next comes the principle involved in the NMR spectroscopy. So first, we will take one proton. So in general, if you take a proton, the proton will be acting as a tiny magnet. It is also having the spin. First, we will check this, whatever the proton we are taking for the NMR spectroscopy, that have the spin or not. That will be decided by the spin quantum number I. If the I value is equal to 0, then it is NMR inactive. If I value is not equal to 0, then it is NMR active. So the question comes, how the I value can be identified. I value of a particular compound can identified by using the atomic number and mass number. Any atom, if you are taking, we can write the atomic number and the mass number of that particular atom. Depending upon the type of the atomic number and mass number, we can identify I value. If per suppose both the atomic number and the mass number are even, then I value will be 0. So just like 6C12 and 16 oxygen 16 8, like that it is I value is 0. So if I value is 0, NMR inactive. Per suppose atomic number and mass number both are odd, then I value will be in the form of ratio, half, 3/2, like that you will get. So that kind of in that situation, I value is not equal to 0. So it is NMR active. For example, 19F9. Next case, next possibility of atomic numbers and mass numbers is one is odd, another one is even, or vice versa. In both the cases, I value is not equal to 0. That indicates that such kind of atoms will be having the spin. So first we will take such kind of atoms whose value I value is not equal to 0. Okay, then what we will do, when a charged particle such as a proton spinning on its axis, it creates a magnetic field. Just like this, it creates a magnetic field. Imagine that a molecule is a tiny bar magnet. These nuclear movements are randomly placed, but in the presence of an external magnetic field. Here we are applying, in absence of external magnetic field, the nuclear magnets of protons are randomly orienting in different directions. Here what we are doing, we are applying the external magnetic field. Once you are applying the external magnetic field in such a direction, here B0 is the external magnetic field. This is the direction of it. Some of the protons will align in the direction of the external magnetic field. Some of the protons will not align. That means in the opposite direction, they will be aligning with the external magnetic field. thereby here creates two different energy levels. Just like they can be called as a different energy levels can be called as a nuclear energy levels. So because of these difference, so some energy gap is created between these two. So that energy gap is, you can make it as a E naught. Now, what we will do in the next step, we will apply radio frequency. Once the radio frequency is applied, the transition, nuclear spin transition will take place from lower energy to higher energy. Here the question arises, which one is the lower energy, which one is the higher energy. So the protons which are aligning in the same direction of a magnetic field, that is having the lower energy, that is the lower energy level, and where the protons having opposite direct align in the opposite direction like this, they will be occupying the higher energy level, thereby supplying the radio frequency, the lower energy to higher energy level, the transition takes place. Nuclear transition will takes place. In order to do the transition, delta E, whatever the energy gap between these two, that much of energy should be supplied, thereby the nuclear spin will takes place. After that, what happens, it anyway, in the higher energy level, the particular nuclear is, the particular proton is very, very unstable. It will be coming back to its original position to the lower energy level. So while doing this process, the delta E and the delta E is the absorption energy, whereas the proton is coming from higher energy to lower energy. It will also releases some amount of energy, that is emission energy. If both are matching with each other, then we will get a resonance. Then we will get a signal in the magnet NMR spectra. That is the principle involved in the NMR spectroscopy. Next comes applications of NMR spectroscopy. It is having various applications. The primary application of NMR or in the field of structure determination and delineation. Next, the type of atoms present in a sample. Next, the relative amounts of atoms present in a sample. The specific environments of atoms within a molecule. The purity and composition of a sample. Structural diagnosis by NMR qualitative analysis. These are all some of the applications of NMR spectroscopy. Thank you, everyone.